Hello guys, welcome again to another video. In this video, we're gonna explore the solution for homework 4. Homework 4 is about flag register. It was an easy, homework. Maybe the last question is a little bit tricky, but when we explore the solution, it's really simple and it's really easy. So let's go into it. So let's start by the first one. We have here two instructions. And we want to see, 5 bits. What would be the final values in 5 bits of the flag register after executing these two instructions? Basically, the carry flag, auxiliary carry flag, parity flag, zero flag, and sign flag. We have here the solution, but of course we're gonna redo, in details how we end up with this solution. Okay, so in the first instruction, we move 38 hexadecimal into BH. Okay, then we add to BH 3F, and of course BH has 38, so we're gonna add basically 38 hexadecimal to 3F hexadecimal, and the result will go, of course, to BH. One note here, the first instruction doesn't change the flag register. So the first instruction, the move doesn't change the flag register. And in general, the transfer instructions doesn't change the flag register. But instructions like arithmetic instruction like add does change. So we are expecting that the change will happen after executing the second instruction, which is adding 38H hexadecimal to 3F hexadecimal. So let's convert, both numbers into binary and see how to add them together. That's a very easy task because, as we said, to convert a hexadecimal number to a binary, you take each digit and write it in 4 bits. So 8 is just 1 0 0 0. 3 is 0 0 1 1. 3F 0 0 1 1 for the 3, and the F is 4 ones. Let's add them together. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 1 is 0, and we have a carry of 1. And before you continue, we said that the auxiliary flag happen if you have a carry from the 4th bit to the 5th bit. This is the 4th bit here. This is the 5th bit. So we have a carry. So the auxiliary flag is 1. That's really, correct. Now we continue. 1 plus 1 plus 1 is 3. 3 is 1 1, which is 1, and we have a carry of 1. Again, 1 plus 1 plus 1 is again 3, which is 1, and we have a carry of 1. 1 plus 0 is 1. 0 plus 0 is 0, and we don't have a carry, so the final carry is 0. Now for the parity, just count the number of ones. If the number of ones is even, then the parity would be 1. If the number of ones is odd, the parity will be 0. Here we have 6 ones. 3 ones here and 3 ones here, so 6 ones. That's an even number, so the parity is 1. The zero flag will be 1 if the output is 0, but clearly this output is not 0, so the zero flag is 0. So again, the zero flag become 1 if the output or the result of the output or the arithmetic operation is 0. This arithmetic operation doesn't, result in a 0. The output is basically 77H. So the conversion of that guy to hexadecimal is 77 hexadecimal. So that's clearly not 0. So the zero flag is 0. A sign flag, we just look at, the 8 or the, the 8th bit, which is 0 here, and that would be the sign. So the sign is 0. Good. Now let's go to the second question here. That's again very similar. So we are adding here FF and 1. It's again the same stuff, but just changing the number. So we're adding FF, which is 1, 1, 1, 1, and the other F is 1, 1, 1, 1. And I usually separate, the two digits just to, so when you have an auxiliary flag, instantly that the auxiliary flag will be 1. And the 0, 1 is basically, 0 here and 1 here. Let's add these together. So 1 plus 1 is 0, and we have a carry of 1. 1 plus 1, 0, and plus 0 is, again 0, and we have a carry of 1. 1 plus 1 plus 0 is 2, which is, again 0, and we have a carry of 1. 1 plus 1 plus 0 is again 2, which is 0, and we have a carry of 1. And before you continue, since you have a carry from the 4th bit to the 5th bit, then the auxiliary flag is 1. 1 plus 1 plus 0 is again 0, and we have a carry of 1. 1 plus 1 plus 0 is again 2, which is 0, and we have a carry of 1. 1 plus 1 plus 0 is again 2, which is 0, and we have a carry of 1. 1 plus 1 plus 0 is again 0, and we have a carry of 1. And we finish. So the carry flag is 1 now. Now look at the result. The result is 0, right? So the 0 flag is 1. So the 0 flag become 1 if you have a 0 output. That's a 0 output. Now for the parity, count the number of ones. If it's even, then the parity flag is 1. Here the number of ones is 0. There is no ones basically. And the 0 is considered an even number, so the parity flag is 1. And the sign flag, just look at the, the last bit number 8, and it's 0, so sign flag is 0. Good. Okay, the third question. Again, same stuff, but now it's 16 bits. And we are using here BX because it's 16. So again, we're gonna do the, the addition, and we're gonna look at the output and, judge from the output. So we are adding here 3, 4, FF. 3 is 0, 0, 1, 1. 4 is 0, 1, 0, 0. FF. Then to FF 3, 4. So FF. And 3 is 0, 0, 1, 1, and 4 is 0, 1, 0, 0. So let's do that. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 0, and we have a carry of 1. 1 plus 1 is 2, which is 0, and we have a carry of 1. And before you continue, the auxiliary flag is 1. So the auxiliary flag always, a carry from the 4th bit to the 5th bit, from bit number 3, because we start counting from 0. So we can say 4th or number 3 to the 5th bit, which is bit number 4. Okay, let's continue. 1 plus 1 plus 1 is 3, which is 1, and we have a carry of 1. 1 plus 1 plus 1 is 3, which is 1, and we have a carry of 1. 1 plus 1 plus 0 is 2, which is 0, and we have a carry of 1. 1 plus 1 is 2, which is 0, and we have a carry of 1. 1 plus 0 plus 1, 2. 1 plus 0 plus 1, again 2. 1 plus 1 plus 1 is 3. 1 plus 0 plus 1 is 2. 1 plus 1 plus 1 is 3. 1 plus 1 plus 1 is 3 again. 1 plus 0 plus 1 is 2. 1 plus 0 plus 1 is 2, so 0, and we have a carry of 1, so the carry flag is 1. Now for the parity, that's a bit fall here. Also, we mentioned in the lecture clearly in two examples that if you have a 16-bit or more, the parity is always the number of ones in the first 8-bit, in the least significant 8-bit. Don't count the number of ones in all the bits. 16 bits here. No, just the first 8 bits. And we have here 4 ones. Even number, so the parity is 1. If you count the number of ones in all, the output, it's a 7, which is odd. So you're gonna say, oh, it's a 0. No, that's wrong. The 0 flag, since the output is not 0, this doesn't equal to 0. So the 0 flag will be 0. And the sign, just look at the final bit, which is 0, so the sign is 0. Good. That's the last question. This is maybe a little bit tricky, although it's really simple, as we're gonna see now. Okay, so if you move here with the question, I mean, if you follow the program, this is an easy program. In each time you decrement Cx, okay, until Cx become 1. So in the last iteration, what's gonna happen is that you decrement Cx. So you are saying 1 minus 1. So let's do it. Cx is 16 bits. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. And you are decrementing Cx, you are subtracting 1 from this. So again, you should write the ones that you should decrement in 16-bit format like this. And let's make the subtraction. 1 minus 1 is 0, 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 is 0, and you have everything is 0 here. Everything is 0. Good. This will change because this is a decrement. Decrement is like subtraction. So this will change the flag register. Let's see the flag, it changes, then we're gonna judge on that instruction, that instruction. Okay, so here there is no carry, so the carry is 0. There is no carry from the 4th bit to the 5th bit, so the auxiliary flag is 0. The number of ones here in the first 8 bits is 0 ones, which is an even number, so the parity is 1. That's equal to 0, so the 0 flag is 1. And the last bit here is 0, so the sign flag is 0. Good. So the flag register 5 bits, is carry flag, auxiliary flag, parity flag, 0 flag, and sign flag. When we execute, that instruction on the 5th iteration will be like this: 0, 0, 1, 1, 0. Okay, then we're gonna execute that instruction. Jump instruction doesn't change the flag, so it will remain like this after jump not 0 again. And it will not jump because it's 0. We are saying jump not 0 means if it's 0, jump. Here it's 0, so it will not jump. So we're gonna execute the move instruction. As we said in the beginning of that video, move instruction, and of course we said this also, when we explained the flag registers, a transfer instruction like move doesn't change the flag register. So again, these values 0, 0, 1, 1, 0 will will stay, will not change after executing jump not 0 again and the move sum and the x. Okay guys, that was basically the solution for homework 4. Thank you very much for watching this video, and see you in another video. Bye bye.